Resistors in parallel all share the same voltage, right? So resistors in the resistance in series problem, they all share the same current because if current goes through one, it has to go through the other. Resistors in parallel all share the same voltage, and they maybe have different currents depending on what their resistances are. And the way they add up is inversely like this. So their inverses add, right? And we can write that like this equation here where the total resistance is the sum of all the inverse resistances, and then we invert that at the end. All right, so if we're going to do this with this problem, right, so we have our total resistance, there we go, RT, is, so 1 over 149 ohms plus 1 over 205 ohms plus 1 over 197 ohms. And then we have to take whatever we get out of that and invert it, right, to get to the total resistance. So let's start by just summing up. I'm going to just type them in first. So 149, 205, and 197. So I need the inverse, the sum of the inverse, 1 over that, plus 1 over that, plus 1 over that. And when you do this, you'll see, oh, right, that number is not at all like these, right? Well, that's because we haven't done the last step yet, which is then invert the answer at the end, right? Which is just 1 over, or I could just take it as the equation states, that to the minus 1. Right, and now 59.92 is what we get here. So let me first 1669 0.0 1669 per ohm. Right? And then we got out of that 59.92 ohms. Now one thing you'll notice here, this 59.92 ohms, the result of adding up all these resistors in series, in parallel, is less than any one of these. And that is always going to be true. The result of adding resistors in parallel is going to be less resistance than the smallest of the resistors you're adding in parallel. Why? You're giving the current options, right? And because the current has options, the total resistance is now less. And that's it for this problem.